we'll make a first simple geometry node setup to detect this collision and extract some information regarding the speed and the terrain the foot is hitting, and then we'll make a simple script to transform this information to a MIDI file which will be able to convert to audio using another piece of software. So you can hide the simulation collection. So let's create a new object with a single vertex in the character collection called fit contact. Merge the vertices at the center and add a new geometry node setup, fit contact. Now for this, we need both our shoes set to relative, and we can right away convert the geometry to some convex hulls so it will be easier to compute. Perfect. Now we also need the terrain collision realized in order to get all the attributes we need when the feet are colliding with the ground. So now let's set up the attributes we will need for the MIDI file. With some store named attributes node, we will need two Boolean attributes, which are going to be contact left and contact right. After this, we also need two integer values, which are going to be the biome under the left foot and the biome under the right foot. And finally, we need a float value, which is going to be the speed. Now, in order to detect the collision, we can add a raycast node, which are going to compute from the point of view of a shoe targeting the collision. And here we can set the ray length as a new input, so it will act as a threshold for detection. So let's, for example, put 1 centimeter and see how it looks. And as you can see, some points of the foot are hitting the ground. From this, we can take an attribute statistic node, and if we plug in our geometry and take a look at the max value, everything should light up as soon as we have contact with the ground. Now we can duplicate this second node for the second shoe, and it should also be working. Perfect. Now we can already store those max values into the booleans we set before. So for the shoe left, contact left, and shoe right, contact right. And now let's compute the attributes. The attributes we want to detect is the biome. So let's see if it's detected correctly. Here we seem to be at a bridge and we are hitting with the value of 1. And for this, just for simplicity's sake, we can just also compute the maximum value. So we can Ctrl-Shift-D duplicate those two nodes, set the attributes to the attributes from the raycast, and again, set the max value to the biome left and biome right. And finally, for the speed, we can just take the name attribute from the state, which we can put into a simple index node plugged into our terrain collision with a simple index of 0. And to get the speed, we can just go onto our terrain nodes group and copy and paste the state value blend for the speeds. Now let's see how the attributes are looking. So here we have contact with the left foot on the biome of index 1, and everything seems to be updating correctly. Also, make sure this is set to integer and nearest so that it doesn't do weird blends between our biomes. Now this is the whole of the setup of the collision detection and setting up of the attributes for the foot collisions. And now let's write the Python script to convert those attributes over time to a MIDI file. On the scripting tab, create a new text and name it fit contact to MIDI. We'll begin by importing a few modules. First, as usual, the Blender Python module, then the OS module to work with the file path. We'll also need the interp method from the numpy module, which will act as a map range. And to write MIDI, we need to install the MIDI util module, and for that there are plenty of tutorials or add-ons to install specific Python modules to Blender, and you can find this module here. And we just need to import from the MIDI file the MIDI file method. Then we need to get the info from the scene, and just like for the strip time script, we need to select an object and realize its information to get the data from the geometry node modifier into the Python script. So let's get our object, deselect everything else, set the object to active, and select it. Now let's initialize the MIDI file. We need to set the number of tracks we want. In our case, we have 4 different biomes, so we need 4 tracks to support this. Now we need to set the time of the file to the start, and to initialize the different tracks, we first need to compute a tempo. For this, I will synchronize it with the FPS count, and I will set the tempo to the FPS times 6, so that everything will more or less line up to the frame count, because the finest resolution at which we will compute this script and generate the MIDI file will be 30 FPS. Now let's add the different tracks for our biomes. For this I will initialize a name for the tracks, and this is just a description of the biomes I implemented in the geometry node setup. And now let's iterate on the name to create the different tracks and add the tempos. Now we will not use channels, so we set this to 0. And as we just want to generate a MIDI note when the foot is first making contact with the ground, we need to initialize some contact values, and then we'll just test from frame to frame if the contact was already made at the frame before in order to trigger a note or not. Now let's iterate over all the frame like in the strip time setup. +1 so you can reach the last frame. Let's set the playhead to the current frame and realize the information of the object, so we can get the data from the geometry node setup. Now let's get all of our attributes from the geometry node setup, which we can get with the realized version of the object, and in other attributes we need to get them by their name, which we set up in the geometry node setup, and our object only has one vertex, so we can get the data at index 0, and we want its value. So we can do this for all the 5 attributes. Now let's check if a new contact has been made with the ground. For the 2 feet. And now let's add a note if either of those 2 conditions are met. For this we will need a pitch, which I am just going to randomly set to 50. Just a quick note from future me, you should actually set this note to 36 so that it corresponds to C1. A note duration, which we can set to 1. For the volume of the note, we can map the speed of the character to the velocity of the MIDI note, so that if it is going faster, the note will be more powerful, which we can do with the inter method we imported earlier, and we'll interpolate the speed in the range of around 1 to 6 meters per second to a range of velocity of, let's say, around 10 to 127, as the values goes from 0 to 127. Now we need to cast this to an integer value. Now we need to compute the time at which we want to set this note in the MIDI file, and because of the way we set up the tempo, the time will just be our frame divided by 10, which we can offset by the start frame of the scene just to be safe. And now we can finally add the note to the MIDI file. So let's add note. Now we want to select the track on which we want to add this note. So if the contact was made on the right, the track will be the biome index on the right, as we can just take the biome on the left, and let's finally add this note to the MIDI track, just like this. Finally, we need to set the values for the next loop, and this is it for the generation of the MIDI file in the loop. Now we just need to save it. So let's give it a file name, and for the path in which to save it, I'm just going to save it to the same directory as our Blender file, which we can get by getting the blend path of the file, trimming it down to get only the directory with the OS function, and we can add the file name to this path with OS path join. And finally, to save this, we need to open a new file like this and write the file. Just a quick correction. And now let's try this out. As usual, this script will also be available for free on my GitHub at this link, and I might even turn this principle into an add-on in the future, so stay tuned. Now, in order to use the MIDI track we just created, You can use basically any DAW, but here I'm using Ableton Live 10 Intro. So go into the arrangement view, and here we can drag in our MIDI file. So here we have our 4 MIDI tracks for the 4 different biomes we set before. Right now, if you press play, nothing will happen because those are just MIDI information and we need to assign them to some sounds. Here I will be using the 40+ free footstep Foley sound effect for sound design, which is available on premiumbeat.com. You can just download this pack, and in it you will find a bunch of audio files that we will be able to use for the different sounds that we want. Here the audio tracks are made of a bunch of different feed sounds, one after the other, so we need to find a way to kind of cut them and assign each different sound to a note. In Ableton, we can do that with the simpler instrument, which you can drag onto the first MIDI track. On the first track, which corresponds to the dirt biome, I am going to drag in the dirt_jogging.mp3 file right here. Now the first thing we need to do is go into the slice mode. Here, instead of trigger, we want to set it to gate, so that each note will only play during the duration of the MIDI note we created from Blender. And from the start, it is starting to slice by transient. In this case, to make sure it is detecting everything correctly, we can lower a bit the sensitivity. Now if we press play, we should be hearing some first sounds. At the moment, the only sound which is triggering is the first one, which should be the case if you put 24 as the MIDI value for each note. As you can see, if you double click on one track, all of the notes are the same, only their velocity is different at the moment. So let's go back on the track itself. Here I am just going to trim a bit the start, and now we'll add some randomness so that each new note triggers a different sound from this sliced sample. Here under MIDI effect, we can just take the random object and put it right here and make sure it is set to add, and we need to set the chance to 100% so that each note will be random. And now if we press play, each song that will be played will be picked between the 12 different choices we have here. So in the case of the dirt jogging track, because we have way more than 12 samples, we can increase this value by quite a bit. Now let's copy and paste those ones for the 2 last MIDI tracks, for the rocky track and the bushes. On the rocky track, let's set the sample to gravel_jogging.mp3. Here we can also play with the settings of sensitivity. And if you don't like the samples we are getting, we can just set it to manual. Here we can zoom in on it, and we can just double click each time we see a transition that we like. Let's do this a dozen of times. And if you don't have that many samples, make sure to lower the choice amount. Now let's do the same with the bushes track. For this one I will use Rattling Through Brush. Here I will also slice manually. And let's also increase the gain a bit so you can better see everything. And finally, for the bridge, we can use the normal boots walking in the simpler. Here I will also set the slicing to manual. Now, once everything has been set up, we can go back to the session view and adjust a bit the volumes so that everything is perceptually the same. Now this is just the base setup, but with this you can then go as fancy as you like, and if you are a bit more comfortable in a DAW, you can just add a lot of different effects to the tracks, randomize a bunch more parameters, and so on. But for this purpose, this is already a great start to get really cool procedural sound using Blender to create MIDI tracks and sample it in Ableton. Now we'll export this under File, Export Audio, and I will leave everything as it is. And here is how it sounds for me. And let's finally prepare for the final render of this animation. First, let's go over our lighting setup one more time. The main environment is pretty dark, with the default gray value set to a strength of 0.1. Then we have a simple sunlight coming from the backside of the character with a strength of 10, and it kind of acts as the stark rim light on the character. Then we have our key light on the front of the character with strength of 1,500 watts, radius of 0.15. We also have a fill light on the backside of the character, which helps to bring the character and some parts of the environment out of the darkness. And we also have another rim light on the front, which is mainly visible on the environment itself. And the final touch is a simple area light near the legs of the character in the back, and it simply allows for the metallic parts of my character to reflect on something. For the render settings, I will make my final render at 1024 samples with the denoiser set to open image denoise. Under light path, I will tweak some of those values. I will set the total number of rays to 12. We don't have that much transparent objects in the scene, but we still have a few of them, so let's set the transparent to 8 just to be safe. Volume we can set to 0 because we have none of that. And transmission, glossy and diffuse I will set to 4. The clumping I will let at the default parameters. We don't have much really reflective objects in the scene, so we don't need caustics. Under film, I'm checking transparent so I can add a background in the compositing step. And under performance, I'm using tiling. The acceleration structure, I use spatial splits, curve BVH, and I will check persistent data so that the data will be loaded in the RAM one time and not be called back at each frame, increasing the render time. Under color management, I'm just set into sRGB. View transform filmic log with no look applied. I didn't tweak the exposure on gamma, and I am also sequencing in sRGB. Under the output settings, my resolution is just a simple HD but in portrait mode. Frame rate is set to 30 FPS. I'm rendering 500 frames. And the file format I set to OpenEXR multi-layer, which I am just setting to half mode, so it doesn't take too much space on my disk. And now we are finally ready for the render, which might take some time to start, but then it will get going pretty fast. With those settings, I am working at under 20 seconds per frame, using both my RTX 3080 Ti GPU from NVIDIA and my brand new RTX 4080 also from NVIDIA, which is really fast for this kind of render. It's finally time for the last step of the making of our little animation, which is the compositing of editing everything together. For this, I will be using DaVinci Resolve, to which I recently switched from long years running on Premiere Pro. So first, when you made a new project, under Files and Project Settings, we need to change the timeline frame rates to 30 FPS. Also, because we rendered everything in vertical, we can hit Use Vertical Resolution, hit Save. Now let's import our assets. First, for the animation, I like to import it under the Media tab, so I can really easily check if the animation and all the frames have been recognized properly. Here, for example, I will just drag in my outputs folder from Blender, in which I have a bunch of different versions of my render, but if I pick one, I can just drag in onto the bottom part right here. And if the animation is not recognized on your side, you can just hit the three little points right here, and under Frame Display Mode, make sure you are in sequence mode and not individual. Now let's go to the Edit tab, and I will also drag in the audio track we just regenerated from Ableton, and right-click on your animated sequence and create new timeline using selected clips. Give it a name, and here is your last chance to change the project settings if you didn't set it to 30 FPS and vertical mode. Let's also drag our audio track, which is a bit longer, but this is normal because of the duration of the last MIDI note, which might be a bit longer. So to do this cleanly, we can just cut this. Using the blade edit mode by hitting C, we can just cut this part and move it at the beginning, like this. Now the EXR sequence we imported is really dark, because the values are encoded in a way which will allow us to retrieve way more value than if we use PNG sequence. So let's make this look good. Let's go to the color tab, and right here we have our color correction node and all the dials and everything that you can use. Here, if the layout is strange, you can just reset the layout, so you can have the color wheels and the curve, so you can tweak your image. Now there is actually a way to import the Blender color profiles right into DaVinci Resolve, so you can directly get a really good looking shot by retrieving the information Blender used, but I will not go over that. So instead, let's just use the color wheels to adjust your image. A gamma adjustment is usually the first step for this, and you can also play around with the gain to retrieve all the color information from your render. If you made some first adjustments, you can right click on this first node and add the serial node. Using the curves, I am bringing down the dark values just a bit, so those are very minor adjustments, but we can see the effect. Now I just want to improve the saturation a bit, and those really simple adjustments will work fine for me. Then let's go back onto the Edit tab. Here with the inspector open, I will just increase the volume of our audio track, and everything seems to be synced up really properly. Next, regarding the audio, I would like to add a few ambient sounds, and for this I usually use Soundly, which is a really nice little piece of software from which you can directly browse a wide range of sound effects and directly drag them right into your software of choice. So right here I will search for nature sounds and browse everything a bit. And I just want a slight environmental hum with some birds and so on. Here I can just select a portion I like and drag it right in DaVinci Resolve. And after adjusting the levels a bit, the sound design is ready for me. Now let's add a background to this. Under Workspace and Show panel, you can add the Effect panel. And from this, I just want to find our generator, the simple grayscale generator, which I will put right under our main layer. And let's tweak this a bit. First, let's rotate it by minus 90 degrees and let's zoom in. Now, it's a bit too bright for me on the bottom, so I'm just reducing the opacity a bit, and I think it will look fine for me. And now with everything ready, just because we made everything loop, we can select our animation, the grayscales, and the two parts of its audio track, and by pressing Alt, we can just shift everything and duplicate it to make it loop a second time. Now let's trim down 2 audio files for the environment and add some small audio transition to this, just so it's a bit more seamless from the start to the end. Now let's move on to the Deliver tab, and for the export settings, you can just set the format to QuickTime and codec to H.264. Everything else I can leave at default, and I just need to set up the file name and export it. Add to render queue and render all. And here is our final result. Hope you learned some interesting things from any of those videos, and hope you like the results. Feel free to reach out to me if you have any question, and thank you for watching this whole series, and I hope to see you next time.